Hello everyone, my name is Alicia Serfati de Marcos and I have created this animation to explain in a simple and clear way how to add rational expressions. What is a rational expression? As fractions are ratios of numbers, that is the division of two numbers. Rational expressions are ratios, in this case of polynomials. That is, it's a division of polynomials. Here you see some examples of rational expressions. With the same rules that we add fractions, we can add rational expressions. And in the same way that we subtract fractions, we can subtract rational expressions as well. In this animation, I will present a four-step process to combine rational expression. And as an example, I will add these two simple rational expressions. In step 1, the first step in the process is that of the recognition of the least common denominator. In this example, the denominators x minus 1 and x plus 2 are clearly different. Therefore, the LCD is just the product of these two factors, x minus 1 times x plus 2. Why we want to know what is the least common denominator? Because fractions with same denominators can be added or subtracted very direct and easy. Therefore, if I just could have the same denominator in my rational expressions, I could combine them very easily. And that same denominator, of course, will be the LCD. And that takes us to step number 2. In step 2, I will use forms of 1 to multiply my fractions in order to get them the same denominator, that is, the LCD. Recall an important property of the real numbers that says that if a number is multiplied by 1 or a form of 1, the result is the same number. That is, if I multiply my rational expressions by 1 or a form of 1, my fractions remains the same. Recall also that a form of 1 can be any fraction whose numerator is equal to the denominator. By multiplying my rational expressions by forms of 1, like x plus 2 divided by x plus 2, and x minus 1 divided by x minus 1, I will obtain that each fraction has now the same denominator, which of course is the least common denominator. Now our fractions are ready to combine into a single fraction, and that takes us to step 3. Step 3. In this step, we combine our two rational expressions into one fraction, whose denominator is the LCD and whose numerator is indicated by this big cloud that has all the numerators and their operations of multiplications and additions, or subtractions if that was the case. Now we see this cloud landing on the top of my single fraction. Now our single rational expression look like this. At this point of the animation, I would like to return to the more traditional mathematical format for our factors and terms. And that takes us to step 4. The last step is that of simplification. We will simplify the numerator by completing the multiplication pending and collecting the like terms. We will not distribute the factors in the denominator for two reasons. First, those factors make visible for what values of x the expressions are undefined. That will happen when x is equal -2 and x equal 1. Second, keeping these factors will make easier the simplification if the same factors in the numerator appears. We can see that the numerator 3x plus 3 can also be expressed in factor form as 3 times x plus 1. Since none of the factors in the numerator equals those on the denominator, we cannot simplify any further. In this way, we have finished the addition of rational expression. We have obtained a final result giving us 3 times x plus 1 divided by x plus 2 times x minus 1. This simple four-step process can be used to combine, by addition or subtraction, more complicated rational expressions, as illustrated in another animation video with an example using 3 rational expressions. I hope this animation can help you realize that the rules of addition and subtraction are quite simple and are the same for fractions, rational expressions, and in general for any algebraic ratio. This four-step process will help us to solve equations involving rational expressions, as shown in another animation video I have prepared for you. Thanks for watching. See you soon.